I'm Bill Newhauser. I'm the senior technical specialist here with ATG. I've been in the industry now for, I'm losing count now, 14, 15 years. So prior to that, I was in the consulting side of life back in the early 90s. So I've been using Civil 3D pretty much since it came out, Land Desktop since it came out. And then prior to that, some software called DCA for you, us old folks. But so what we're going to talk about today here, I'm going to get into a little more in depth here on the CTC tool, the what they call the Earthwork Processor. Now, I'm not going to dig too deep in the Earthwork Processor itself. What I'm going to try to show here is how you get your drawing set up for the Earthwork Processor. Okay, if you want to know about the Earthwork Processor, I'll show you in a minute here. We got a ton of videos out there already, showing ins and outs of the Earthwork Processor itself. The issue is that it's always with some stock demo files that are pre-set up. Well, I'm going to essentially want to show you guys how to set up, for those demo files on the backside. So in other words, taking a somewhat real drawing here and getting it ready to run in Earthwork Processor. And believe me, there's a lot to the sausage, a lot inside of that sausage to get it set up and running and making sure it's doing what you want to do. Also, in the process of me getting ready for this webinar, I've been using the CTC tools here for about 5 months now, 4 or 5 months, and slowly getting into it deeper and deeper myself. And so I'm probably kind of like most of you guys, is that I haven't used it a whole lot, so this has been a big learning process for me. And again, my objective here was to ultimately cover how to get your drawing and your design ready to use, I'll call it EP or Earthwork Processor, because there is a lot to it in the background. So I want to show you guys that process. The software is great if everything's all set up for you. So it's getting it set up. So we're going to go through here. We'll talk about curbs, island, grass, pavement areas. I'm going to show you, I've got an alignment drawn in my sample here. And the alignments are mostly just to kind of, it gives me a way to cross section through here to verify what's going on. We're going to define the materials to a certain degree. I'll show you in some typical sections here what we're talking about there. We're going to separate everything into different layers, and you'll see why in a minute here too. And then we'll run through the numbers here. But so our agenda here is getting ready for the drawing, getting the drawing ready, layer naming, what goes where, determining the offsets and elevations and to create the datum surface, running the offsets for each region, running the calculated earthworks, cut, fill, and stripping, and verifying, make sure they're doing what we think it's doing. Now you can see here the little sample I've got down here in the bottom right here, typical section through here, and I'm going to show you kind of digging deep here, what we're looking at. So getting the drawing ready here, layer names. What I've done, and I'm trying to match this to national CAD standards in the layer naming. Okay, so the C topo grade, M, just I picked that. I'm calling it manual because I'm manually creating this stuff. Okay, off of that, I'm going to have a different layer for each. How should I say? Each substratum that we're looking at. So we're gonna asphalt. We got sidewalk. We got concrete. Those type of items, that make up a typical, say, parking lot. And so I want to make sure that those lines are going to go onto separate layers, because on those separate layers, one of the things we have to set here is the elevation of that layer, which is determine the thickness of that particular area down to the datum surface. And I'll show you that here in a second here too. So here's a couple of examples here of layer names. And all this is telling me here is that it's asphalt. The elevation of the asphalt is I can't put a period here, so it's 1.49, so 1.49 feet. The back of curb one here is 2.02 feet, and the sod is down D5, which is 0.5 foot. Okay, and if you look down here in the bottom here, I've drawn this in here and showed here what's going on here. So I got sod here the offset's 1.1 foot, and the elevation is 0.5 feet. Now, the elevations, all that is telling me the thickness. So kind of think of that in inverse order. So I'm kind of basing everything off of here of the top surface here that you will have had created prior to jumping into this. Okay, we're not going to get into that at all. In fact, the simplified thing to show you guys better what's going on here, I have a flat surface out here. I'm assuming my finished ground surface is flat out here, just for simplicity's sake. Okay, in real life, it would be this cyan line here. Okay, this is something that you, the designer, would have to have created already ahead of time, and that's probably going to be done by feature lines, points, maybe a corridor, whatever. Okay, but that you're going to have to come up with first prior to these steps. Okay, what I'm going to show you guys here is how we get the software to give us this green datum line here. Okay, and I'll show you a little more depth here in the next screen here. So let's go to the next one here. Okay, so getting the drawing ready. Okay, so as you can see up on top here, I've got a typical, and I'll show you over in the drawing here in a minute here too, but I've got, what I did is I took an aerial of an existing parking lot, and I went around and I tried to trace out where the sidewalk was, where the curb was, where the asphalt was, etc. And ultimately what I've got here is I've got a bunch of lines piled on top of each other. And what I'm finding here is the best thing to do is to, right on the back of curb is what I chose, is I've got a pile of these lines stacked on top of each other. Okay, and what we're going to do here is we got a tool in here in the Earthwork Processor that will help us offset those, because we all know one of the most difficult parts of offsetting a pollen line is offsetting a weird shaped pollen line with curbs and inside vertices or inside corners, outside corners, etc. And the little utility we've got in here does an amazing job of that. Okay, because really, what we're trying to do here is we're trying to get the computer to figure out the datum surface for us. Okay, because think about this: when you do a parking lot and you lay out your finished ground surface, okay, that's the top of the surface. That looks really pretty. It's all really nice and so forth. Great for staking the top, but in real life, we have our structure. Okay, we're going to have our curb, we're going to have our base, we're going to have our asphalt, we're going to have our subgrade underneath the asphalt, etc. And we got our sodded areas. Okay, we've got our areas where we got sidewalk and so forth too, and all that stuff has different thicknesses to it. And so what we're trying to do here is we're trying to figure out what our cut and fill is to the bottom of our structure, which is what we call the datum surface here, as you see right here in the middle. Okay, and up here is the top surface, and again, this has been already created by the designer. And so what the software is going to do here is it's going to take this line here, based upon the criteria we give it, it's going to offset. It's like, say in this area where we have our sod, it's going to offset this down 0.5 feet. And then over here where we got our curb area, it's going to offset it down, in this case, 2.5 feet from here to here. And then in this area, it's going to offset it down 1.49 feet. Now, keep in mind, that is the length from this point right here to here is 1.49. This is 2.05 from right here down to here. Okay, so these values, even though it's the same datum, this is with respect to my finished ground surface. So you have to keep that in mind when you're setting this stuff up. Okay, and so what I have done, and let me go look at my drawing here real quick here. I can expand this out here so you can see it. Is I've got the parking lot laid out up here, and if I turn on my aerial, let's turn on temporarily, you can kind of see what's going on here. It's a big parking lot here. I thought about doing the whole parking lot, but I didn't have a month of Sundays to recreate what they had done. And so again, what I did is I outlined, and I'm trying to find the curb area of what's involved here. And then let me turn that off again here. And let me turn on my hatch patterns. And so the end result was this. So I've got my asphalt, I've got my sidewalk, okay, and I've got my sod areas. That's the three areas that I'm concerned with. And the idea is that each of these areas is going to have a different thickness of structure, okay? And so down here in the bottom, what I'm trying to figure out here is that I'm trying to get this set up to where I need to offset these lines. And because these lines right now are basically along a line here down. Okay. And so essentially they are like this particular line right here, right now is actually right here. This one is right here, perpendicular to this. And this one here is right here, perpendicular. So if I was to go look at these lines, look straight down, if I turn off the hatch pattern here, okay, straight down, there's three lines, boom, 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 which is going straight down this line here, okay? If you look over here in 3D, you get a better example here. You can start seeing these. Now I'm looking at this area right down here, and you can see how they're all set up here, and they're all at different elevations here. Okay, if I go in and I highlight one and I go to properties, you'll see the elevation here set up with 0.205, which is that M curb, back of curb D05 or 2.05 outer. Okay, and so this here, this is just standard AutoCAD, nothing special going on here. This is just standard drawing these lines, doing the fillets, making sure they're all closed. The key is that they got to be closed. Okay, closed pollen lines, and they're all stacked on top of each other. Okay, now why is it important? The next step here that we're going to talk about where we start offsetting these is because, well, for one, if I put all these in elevation right, stacked them on top of each other, when I came in here and built my surfaces, the computer is going to have issues. Okay, we all know DTMs have a big time issue with a vertical face, a straight up and down wall, per se. Okay, the problem is we don't know if the line is going to go like this and over and back, or is going to go like this, down, up, and back. Okay, because that face is vertical. Okay, the software is not smart enough to figure that out. Okay, so what we do is we set just a slight offset in any of our vertical lines on our surfaces. We want a slight offset, and so then the computer goes through here and connects the dots in the proper order to determine our datum surface. Okay, now the next thing is, since we're going to offset these a little bit, why not offset them in the correct spot? Okay, if I just offset these 1/10 of a foot either way, fine, that's going to work, but then we're not going to get this back area. We're not going to get this face area. We're not going to account for that as well, and it's going to get a little funky in here. Is it a whole lot of error? Probably not, but if it's a big parking lot, it can add up on you. So I'm trying to get this as close to correct as possible. Okay, so let me go back to my PowerPoint here. So let's talk about this a little more here. So what I've got is, here's that 3D looking at this, and each of these lines here is basically asphalt, back of curb, sidewalk, sod, and their corresponding elevations. Okay, if you look over here, I'm kind of got these arrows kind of pointing to and from which ones they're representing here, but like, keep in mind here, we are going along this line here, and we're trying to take this surface and offset it to create this surface. Okay, so from here to here, this is offset directly down 1/2 foot. From here to here, it's exactly offset 2.05, and from here on out, it's down 1.49 feet. And again, I've got that embedded in the layer names here. Okay, that's to help me, keep track of all this, because believe me, there's a lot to keep track of when you start thinking about this. Okay, so this is for the outer region. The other thing you have to look at when you're looking at these is when we're talking an outer region. Okay, so if I go back to the drawing here, that is this outer area. Okay, and the inner regions are going to be stuff like this inside area. Okay, and that's important because we have to determine when we offset this stuff, which way are we offsetting to reflect the curve, essentially. You reflect these offset values. And a couple of these, it is critical, okay? Because in reality, what we're trying to get is we're trying to get these lines all offset in the right fashion so there's no overlap occurring in these little corners that you see here, okay? So that's okay. So this is the outer regions. So here's the inner regions and islands, as I call them, okay? And you can see the section up here is a little bit different here because, again, we're curves on the right side, curves on the left side. And so these are, I'm naming these a little bit differently. As you see over here, actually, I got another view here, but if you look at my layer names, you'll see here, I've also come in here and I've called them inner, outer, outer, inner. This is the far outside, and inner and inner. Okay. Now this one here, this is unique. This is the very outside. This is kind of like the boundary of my surface, more or less. Okay. That is going to be, I don't know if I can grip on it here. Probably right. Nope. It's turned off right now. I turn it on. Okay, it's that magenta line there. Okay, that's the very outer. Okay, that's something else I've got to create because I need it. This is set up to be in a zero offset, zero elevation. That way the whole surface kind of ties back into existing ground out there. Okay, if not, we end up with a gap on the edges. Okay, and let's go back here. So this one here, you can see here how, this is an inner island here, and we've got curb in here. And keep in mind what I'm trying to do here. And now these values that you see here, this is all based upon your typical section. Now for simplicity, all I did is I used the box stock curb with the lane, and this is I believe it's a sidewalk subassembly. I changed the thickness a little bit here to reflect, but this is just all box stock here, and that's where I got the values off of. So just to let you know, this value right here, if I do a DI inside the drawing and I pick the back of curb, this point here, and I pick this point here, this is just the X value and the Y value. Okay, that's all that is. Okay, nothing special there. So in the drawing here, like I just showed you earlier, this is what we've got going on. We've got asphalt, we've got sod, and we got sidewalk. Okay, so sidewalk, the blue is all sod, the green is all asphalt. Okay, and in the next drawing here, now this is where it starts getting fun here. Now we're actually running the tool, and in the Earthwork processor, when I come up here, when I click here, we have two little commands we run. Okay, this bottom one is the one I'm really showing you here. It's the offset earthwork regions. And this is just kind of more or less a fancy little program that will automate the offset process. Yes, I could come through here using the offset command and offset these manually. Okay, and nothing too special. Again, you run into areas to where when you have too tight of inside curves and stuff, and the software has built in how to fix that. If you use just a standard AutoCAD offset command, it may not get the desired results. Okay, and so that's where this tool comes into play here. So when I run this, this is the command that we're seeing over here. And I'm going through this. And what I found to do is I actually run this, as you'll see each time here, is I've run this once for sod. And here's the settings. Okay. And the sod here is an offset of 1.1. The elevation is 0.5. That's already set. Okay. When I've created those lines in AutoCAD, all you do is you do a select all, right click, go to properties, go to elevation, change the elevation to, in this case, 0.5. Okay, pretty straightforward there. It's the offset setting. That's a different story. That's coming in the Earthwork processor. Okay. And so all we do in there is we pick on this button right here in the middle. Okay. Go pick on an object on that layer and it will extract the layer name. Okay. And then I come up here to offset and I determine, is it inner or outer? And that's why I put the word in here. I'm going to go inward with it at a 1.1. Okay. And then make sure to delete your existing entities when we do this. Now, when we get all this set up, if we click on this middle button here, right here in the middle, this will tell us how many objects it's filtered. So it gives us a rough idea that, hey, it actually did something here. Okay. And then once we click OK, it's going to process and it will actually go through and offset those lines and delete the old lines in the process. Okay, now I'm going to run through this a little bit here and show you guys what I'm talking about. But so I've done this here. So this is for the sod. This is the back of curb. And I'll hold it here for a little bit. So if somebody wants to later in the videos see what settings I've got set up. So this one is set to 1 foot. Okay, and outer. That's the big thing. And there's only one item. And you see here when I gripped on it, it's only showing the one item. Next one here, the asphalt. Again, when I gripped on it, you can see here what it highlighted. Okay. And that is offset 0.66 feet. Okay. And it's 1.49 feet down. Then for the sidewalk, again, when I grip on it, you can see what's highlighting here for sidewalk. And actually, that's actually not right. It should only be these middle blue parts here. So ignore the graphic here. It should be this blue stuff here. I must have still had the old ones highlighted, or maybe not. No, I take that back. I take that back. It is doing it correctly. So I've got sidewalk here, sidewalk here, sidewalk in here, the sidewalk in these areas and so forth. Okay. So yeah, it is doing it correctly. Okay. So then I set the offset. Okay. In this case, I look at the layer name inner. So I'm offsetting inward 1.1 feet. Okay. And I clicked on run. This one here is the island. So I've got one island sitting out here. Okay. And this is offset. It should be 1.1. I've got to set the, well, it should be 1. So I'm off on my graphic here. But, again, it's just that small area. And this one here is my, the island, okay, which is here. Now this one here is a little different because I want to offset this, the outer, okay, because if you think about the island here, your curb is draining that way. And so to get that to work, I've got to offset this line outward, not inward. And so that's where the outer comes into play on this one. And again, this is the kind of stuff that you got to kind of think about a little bit. Make sure you're doing what you think it's doing. Okay. And so it's 0.66 feet in outer. Then this one here is the boundary. And now I go through the process, even though I'm not offsetting this much, I have to offset it something. So I typed in 0.01. And because it's just, I want to make sure this gets added to the surface. Okay. Is all I'm really doing here. And when you're done here, okay, what you want to do is you want to verify what it did. You want to make sure that the offsets occurred in the correct fashion. So you're looking for overlapping lines. Okay, it won't be perfect. There might be some areas that look a little funky, you know. It does a pretty darn good job. I have noticed a couple areas that kind of questionable, but I'll show you one area I'm talking about. But it shouldn't affect the overall numbers by much, if anything at all. Okay, but if you see here, if I zoomed in on this area, you can see the actual offsets. That's at 0.1, 0.1. This must be the bigger values. So, so now once I've done that, okay, then I can go into the Earthwork processor. And when I run this, I come up, I click on this green button right here. And that adds this to the list. I'll give it a name here. I'll just call it Earth. You choose your finished ground surface, your existing ground surface, and then the subgrade regions, you choose by filter. And then I'm using here C topo grade dash, M with an asterisk as a wild card. And when you do that and click OK, it will give you everything, all those regions, it's going to give it to you. Now, what makes my drawing so much different than the other drawings that we've used in the previous demos is that normally there's a region for sod, there's a region for asphalt, and there's a region for curb. Okay. Well, that's great. But in real life, you know, as you saw back in my drawing, go back to it here. You know, if you saw my drawing here, I've got, you know, sod, 1, 2, I got sod areas out here, all these little small areas. I've got curb crossings, you know, or sidewalk crossings here. And then again, I got more sod. So I've got a lot of individual regions going on here. It's not like I can easily say, well, this is all asphalt and this is all sod and we're done. No, you know, this is getting more, you know, can you imagine doing the whole parking lot I showed you? You know, there's a lot of stuff going on here. Okay. And so this time that I'm spending here to get this set up on a typical parking lot, like this is the parking lot for a hospital, a huge hospital. I mean, there's hundreds of parking lot stalls here. Okay. So this process would save an immense amount of time. Yes, it takes a little bit to get set up. Yes, you probably want to test it in a small area like this to make sure it's doing what you want. But ultimately, you know, it's a one-click, boom, it's done type thing. Now, as you can see here, let me show you one of those areas I was referring to. This area right here, which is right here, this was, in this case, our curb, back curb, that's at 2.02 foot mark here. Okay. And when you offset it here, it gets kind of weird. Okay. Now, if I had tried to offset that using the standard AutoCAD command, I'm not sure what would happen. I'm not sure it would be smarter to put a radius in here. Yeah, it might get kind of funky in this area because, you know, it did start off like this. And so that's the kind of stuff, it gets a little weird, but it does its job. And the good news is that it doesn't blow up the surfaces. So when I build the surface, not a big deal. Or I should say when it builds the surface, not a big deal. So let's go back out here. Let me go ahead and just run this a couple times there so you can see what's going on here. So what I'm going to do, let me go back. Let's do this first one, the sod. So sod is at 1.1. And that sod is that line right there. So let's go ahead and have a look. Now, the other thing I do, make life a little easier, I like to keep one view in 3D because obviously when I come in here and try to pick on these lines, I got lines on top of lines on top of lines. So Civil 3 is going to have an issue trying to pick the right one. And it's going to be kind of a little hard to tell which one is the right one. But if I come over here in 3D, I get a little better visualization of what's going on here. Okay, so like here is our sidewalk. There's the sod that we're talking about. So I'm going to go ahead and run this here. Earthwork regions. Create regions. Okay, I'm going to get rid of what I had before and get rid of what's in here. And I'm going to go ahead and pick on that green line. Verify it is what I want. And I'm going to set this at 1.1. And it is enter, and that's great. Now, if I click on this button here, it's going to show me. Now, this comes up, and I'll be honest, it's telling me that I have an open pollen line. I could not find it. I went looking for it, and I could not find it, okay? Typically, so that it's kind of giving me a little warning saying, hey, there's one out there that it's not closed. And I personally, I think there might be like a small entity somewhere just hanging up there, just a single line that I just can't find in my drawing. That's causing this issue. Now, when I do this, it shows me I've got 28 items. Okay, when I actually process it, it's going to run through. And if you saw there, it actually did something in the background. It's doing something as we speak. And it comes up. And it actually moved that line. And over here, it's actually showing me what it did. Okay. Now, I can zoom to them and actually go and see them, hopefully here, to a certain degree. So I can see the areas that it's chose. Okay. I could give it a name. Maybe not. I don't think, I can't give it a name. Okay. But so I'm not sure where it's getting that from. But over to the right here, so make sure that it grabbed everything that I thought it was going, and yes, everything's good. So as you start processing this, you can see here, all of a sudden, see all this line offset? Okay, not just that one, but all of them. And again, zoom in on these areas to see if it looks like it's doing what you think it's doing. And it looks like it is. Okay. Some of these, I think it might get a little, you know, it's not perfect. But again, it does a pretty good job. I mean, look at these. We got a lot of curves here. We all know the offset command and curves can get kind of tricky. Not to mention the fatal errorish. Here, it did it in this corner here too. So again, so the next one that I would do, I'm not going to do them all here, but I'll run through a few here just to, whoops, hit the escape button here. Okay, so the back of curb, and the back of curb one is gonna be, all right, let's do let's do the asphalt. Okay, the asphalt one here, and let's kick back over here. Or actually, let's make sure I got the values right. So it's offset value of 0.66. So this one right here is what we're offsetting here. And so run this again. And clear my previous. Pick on this. And I believe, nope, wrong one. Let me make sure I get the right one here. Click on it. There's our asphalt right there. So it's that red line right there. So again, run this again. Offset. Remove that. Pick on it. It is. And it's supposed to be 0.66. And just to verify it was inner. Okay. Delete. Again, hit this button. And there's only 3 of them. That sounds about right. Go ahead and click OK. Let it do its thing. Again, it gives me a confirmation of what it did. And I can zoom to them and have a look at them. And click OK. Now, next thing here, so I'd run through that whole process, and magically, I'd get this drawing. And as I zoom around here, again, my biggest thing is I want to make sure things are offset correctly. And if I zoom around, you can kind of see what's going on here. Okay, so once you've got everything offset correctly, then I'm going to go into the Earthwork processor and go calculate earthworks. And see these videos up here. For those that want more information on this next step here, okay, if you click on videos, this will take you out to YouTube. And there's a whole boatload of videos here, anywhere from a real quick minute 40 all the way up to typically about 40 minutes to an hour or longer type videos, and some different situations that we're using them in here. Okay, so I'm going to click on this green button here, and I'm just going to call this Earthworks. And my proposed surface, my FG, my existing surface, EG. And now this here is where I can either go through and manually pick on these areas one at a time, which is okay, but I got a lot to pick from, right? But instead, I'm going to go ahead and do filter and click on this button here and tell it how do I want to filter. So the trick here is to go pick on one of these and then come in here and remove that portion of it. Okay, and then put an asterisk there. So that's my wild card. Now you could come in here and choose them by different methods here. Okay, you can also exclude stuff. So if you had a couple layers in here that you didn't want, and they had some kind of a constant to them that you could type in here like outer or inner or whatever, we can exclude them here too. So I'll go ahead and click OK. And again, this is that closed routine. Just give me a little warning. Now, what it did there it went out using that criteria, and you can see here, we got inner, we got asphalt, sod, we got the boundary, we got the curb. Okay, we've got all the different things here. So it was 40 some, if I recall correctly. Okay, over here, the subgrade depth. Now that value is coming right from the elevation of that particular item. Okay, that entity. So if I don't like what I see here, I need to go back out, cancel this, go back out, find that particular item and change it to correct depth. Okay. Now we got a cut factor and fill factor. And this is all totally editable to whatever you want. Okay. Over here, the stripping depth. Okay. This is where we can determine how much do we need to strip in each of these areas. Now, yes, I got to go through there and enter this many times in order to get this right, but this also gives me the ability to strip more in some areas than others. So if I know where something is, I could, and again, you can use this browse button here, the zoom button, to zoom in on the stuff. So I could change these to something else if I needed to. Maybe I got an area where I'm in a wetland or something and I want to strip more. Okay. I could do that through here. So if I come in here and just plug in values, I'll just use 1 for everything. Oh, so only 1 foot of stripping. So I'd go ahead and do that. And then the last thing is here too, I can put a label in here. And the label will put a label, you'll see it here in a minute, it'll actually put a label with their values on it. Also over here, we have the ability to create an AutoCAD table or export to Excel or both, okay? So I'm gonna go ahead and click on Run All. It's gonna process, okay, it's doing 48 regions. Wait for it here. And here's our values. And here's our stripping volumes, etc. Here's the totals for everything. Now, if I pick on this button right here, create AutoCAD table, go pick a spot out here, and then go ahead, wait for it. It's processing that right now. Wait for it. Like watching water boil here. And now we've got a nice table here. Shows you each of the regions. More importantly, though, it gives you a grand total up on the top here. Now let's one thing here too. Let me just show you here. Okay, I've got an alignment here, and I'm gonna do a surface profile, and now we've got our stripping and our subgrade, and I'm going to change the styles on them so it looks a little bit differently here. And click OK. Come up here. Look at my profile here. Now let's kind of get an okay example here. Now keep in mind here that this green line here, remember I told you earlier that for simplicity's sake, I did a finished ground surface. I assume the whole thing is flat. Okay. And it's kind of my way here to verify that I've got the right depths going on here. So it's coming across this way here. And let me see which way station 0. Actually, this is actually down here at the bottom. So it's going along here. That's at outer, which was at 0. It's coming down, looks like 0.5, coming over here, dropping down to 2.2. Then it's going to 1.49, and it's continuing doing that all the way through here. Okay. And we are cutting across here. We've got a median out here, some stuff going on there. And again, it does a pretty good job through most of this. Kind of see where it's going up, down, up, down, up, down. Okay. It might look a little better if I actually had a finished ground surface out here that actually had curb line drawn in here. You know, the curb here, this is going to look funky because yes, I'm going down 2.5 feet and coming back up to the 1.49 feet. But you get the idea. Now, again, my objective here was to show you guys how to get this stuff set up. Okay. Actually running this stuff here, again, that's another training class all by itself. I'm just trying to show you how to get your drawings ready and what to look for. And to kind of come back here and look at my sections here. Again, I'm trying to figure out how we can automate this process. That's the datum surface. That's what we're aiming for. Okay. You have this already. This has already been done. Feature lines, you know, etc. This baby down here, this is the fun one. Trying to come up with that surface. And here's the label that I talked about. It drops in here. Okay, proposed surface, existing surface, cut, fill, and the stripping volumes. But beyond that, let me go out and look here. If I can find my, I don't have any questions or answers in here. Again, this will be saved. It'll be in our ATG library for future reference. I hope this was helpful. Again, the objective here was to show you guys how to get the drawings set up and what needs to be done and some of the little stuff you need to look at. Okay. These numbers that I gave you here, this is based upon the stock sub-assemblies we have in here, assuming a stock curb, etc. These values would all obviously be a little bit different based upon your current design. So, but I hope that helped everybody. I hope there's a little bit different than what we normally throw at you guys here. A little different look at things, but appreciate your time. We're getting done here a little bit earlier. And we will see you next time. And again, my name is Bill Newhauser from ATG, and we'll talk to you later. Thank you.
Hey there, thanks for tuning in. If you like this video, make sure to subscribe and check out some of the other content on our channel.